My name is 𝗧𝗨𝗧𝗘𝗧𝗧𝗧. Welcome back to another video in the series Namaste Google Cloud. In this video, you will learn about few networking concepts such as VPC peering, shared VPCs, and how to implement those. Please watch the complete video as I will be doing some knowledge checks at the end with some sample exam questions if you are planning for Associate Cloud Engineer certification. If you are new to my channel, please hit the subscribe button below and don't forget to hit the bell icon to get notified about all my upcoming videos. Without further ado, let's get into it. Google Cloud VPC network peering allows internal IP addresses connectivity between two VPC networks. Those VPC networks could be from same project or organization or from different projects or organizations. There is no restrictions to that. Traffic remains inside the Google backbone network and don't traverse through the public internet. There are some advantages of using network peering over external IP addresses or VPNs to connect networks. First one is network latency. Connectivity that uses internal IP address provide lower latency than external IP addresses as there are no hops or devices between the peering connection. Service doesn't need to be exposed to the public internet and deal with its associated risks. So it provides a greater network security for your workloads. By using internal IPs, you are saving egress communication cost. So yes, it is a cheaper option than external IP connection. Now let's see how peering works. Consider an organization which needs VPC network peering to be established between network A in project DR and network B in project prod. For VPC network peering to be successfully established, administrator of network A and network B must separately configure the peering association from DR to prod as well as from prod to DR. VPC A has one network subnet with CIDR range as 10.0.0.0/16. Similarly, VPC B has one subnet with CIDR range as 10.8.0.0/16. Make sure that the participating VPCs in a network peering should not have the overlapping CIDR range. Otherwise, there will be a conflict and connection would not be established. Each subnet has a Google Compute Engine which you would want to connect via their private IP addresses. Let's call them VMDR1 for VPC A and VMProd1 for VPC B. From VPC A, you create a connection and enter the project and network you would want to peer with. In this case, which is project prod. In VPC B, you import and export custom routes and create the peering connection. This connection will be created from DR to prod. At this point, the peering state remains inactive as there is no matching configuration in network B in project B. A network admin or a user with appropriate IAM permission in project prod must configure the matching configuration from project DR in order for the peering connection to be active on both ends. You follow the same step from VPC network B to create the connection from prod to DR, and as soon as peering moves to an active state, subnet routes and custom routes are exchanged, and both VM will be able to talk to each other via their private IP addresses. Let's see another example. Over here, VPC A and VPC B are already peered. We created a new network VPC C and wants to peer it with VPC B. Now VPC peering cannot be established in this case as well. You see there is a CIDR range overlap between VPC A and C. It has 10.0.1.0, it has 10.0.1.0. Even though we are trying to peer VPC C with B, but VPC A also is a part of this active connection. So that is why you cannot create the connection between these two as well. Let's have a look at the transitive peering now. So we have three VPC networks, VPC A, VPC B, and VPC C. If VPC A is paired with VPC B and there is an active connection between those from both the ends, And if VPC B is also paired with VPC C and there is active connection between both these VPC, that doesn't mean that VPC A and C are automatically paired. So there is no connection between those two VPCs. And this is what we call as transitive peering. So transitive peering is not supported in Google Cloud Platform. Let's have a look some important points with respect to what we have seen so far. Subnet CIDR range overlapping is not allowed if you wish to peer the networks. Transitive peering is also not supported. You could have a maximum of 25 connections to a single VPC network. That means one VPC could only be paired with 25 other VPCs and not more than that. This is the limitation. To delete a VPC network, you should first delete all the peering configuration in the network and then you can delete the VPC network. Otherwise, it will not allow you to do that. And you would need compute.networkadmin role or the editor role to create or delete the VPC peering. VPC network peering only works with Compute Engine, GKE, and App Engine flexible environment. Other services are not supported because these are the only services that you provision inside a VPC. All right, to follow the steps that we have seen so far, I have logged into my Google Cloud Console and I will be creating two separate VPCs in two of the projects that we have. So first, I'm in my project DR. I'll search for VPC network. Click on Create VPC network. I'll give this a name, VPCA. Then I will create a subnet, call it subnet A, and then I'll select the region as US East 1. Now I'll specify the IP range of this particular subnet. So let's call it 10.0.0.0/16. It'll have 65,000 something IPs. And done. Then I'll select two default firewall rules. One is ICMP, another one is SSH, so that I could SSH into my instance that I'll be provisioning in this VPC, and I could ping the VM from the another VM. Okay, and then keep everything as default, hit create. Now I'll open a new tab and create the VPC in the other project that we have, which is project prod. So click over here in the drop down and select the other project. Okay, now search for the VPC network again and create a new VPC network. Give it a name, VPC-B. Create the subnet in custom mode. Subnet name is subnet B. Region is, earlier we chose US East 1. This time we will be using US West 1. Over here, specify the IP range 10.8.0.0/16. Please make sure that IP range is not overlapping with the other IP range that we have in VPCA. So that's why earlier we chose 10.0.0.0/16. Now we are using 10.8.0.0 so that they don't have any overlapping IPs. Okay, done. The same way we will be using ICMP and SSH default firewall rules. Keep everything as default, hit create. And if we go back to our VPCA and scroll down, our VPC has been provisioned. Now I'll create an instance in this particular VPC. So search for Compute Engine, create instance, give it a name, VM1DR. Select the region as US East 1 because that is where our subnet has been provisioned. Right, US East 1. I'll choose a smaller machine size, E2 micro. Scroll down to the networking section. Over here, advanced options. Expand this and hit networking. Scroll down a bit and you will see your default network interface. So you again click the drop down and change the network from default to VPC-A. Okay, and the instance will be created in the subnet that we have created, and keep rest of the thing as default. Hit done and create. Now let's follow the same step in VPC-B, which is in our next tab. So let's quickly verify VPC-B has been created. It's there. So search for compute engine, create instance, give it a name, VM2 prod, and specify region as US West 1, because in this region our subnet was provisioned. Change the machine type to micro. Scroll down to the networking section and change the default network to VPC-B, and it will auto populate the subnet for you. Done, and create the instance. Now our both the instance in two separate projects and two separate VPCs have been created. The first one is active. Let's log into this. The internal IP is this one. So this is what we're gonna use for our VPC peering. But first let's see how the instance see each other without the peering, right? So I'll just SSH into this VM. All right, I'll clear the screen and let's grab the private IP from the other instance. So this VM is also ready. So I'll just grab the private IP from here, which is 10.8.0.2. Copy this. I'll go back to my SSH window, which is over here. I'll try to ping the prod instance from the DR instance. This is the private IP. Hit enter. And I'm not getting any reply, even though the ICMP port has been enabled. Right, because there is no connectivity between both the instances, as there is no connectivity between those two VMs, as they both were provisioned in two separate projects and two separate VPCs, right? So if you see 100% packet loss, there is no connectivity. Now let's go back to our project DR and create the VPC peering connection. So for that, you go to VPC network and go to VPC network peering over here on the left side. Now create a connection. It says you will need the following info: the project ID if you're connecting to another project, and name of the VPC network that you want to peer with. I'll show you how you can do that. Hit connect, give it a name. Let's call it peering DR to prod. Select the source VPC network, which is VPC-A, and the peer VPC network is in another project. So choose this one in another project and specify the project ID. This is not the project name, but the project ID. So I'll go to the drop down again and I'll grab the project ID from here. This is the project ID of our prod project, right? So I'll copy this, paste it over here, and the VPC network name. Our VPC network name was VPC-B. I'll import custom routes as well as import subnet routes and export it as well. Hit create. Maybe I'll hit refresh. Okay, so the peering connection from DR to prod has been created, but this is just the one side of the connection. You still need to create the other connection from prod to DR. That is why it is showing as inactive currently, right? So I'll go to my project prod, search for VPC networks, and I'll create a new VPC network peering. So you hit create connection, continue, give it a name, peering prod to DR. Select your source VPC network, which is VPC-B. Select the destination VPC peering network, which is in another project, and I'll grab the project ID from here. I need the project ID of project DR. Okay. VPC network name of the destination VPC is VPC A. I'll select all these options to import and export custom routes and subnet routes with public IP. Hit create. So now the connection is showing as active, and if you go to the other VPC that we have from DR to prod and hit refresh, this connection is also active. So once the connection is established between DR and prod, two VPCs, the custom routes will be exchanged and it will be created automatically. If you go to routes, and if you could just filter this by network VPC A, right? So you see three routes have been created. One is default route to the default local route to the subnetwork, the destination of your subnet, and then there is a default route to the internet so that this instance could talk to internet. Another one is route to the peering connection, which is in our prod project, right? And the destination IP is 10.8.0, right? The same way, if you see, the routes will be created in this VPC as well, routes, and filter it by the network name. Network name was VPCB, and the same way three routes will be created over here. Now let's go back to our GCE instance, compute instance, and SSH to the terminal. Okay, let's ping the instance again. And now we are getting reply from there. That means we have successfully peered our VPC connection from DR to prod, and this will work for other way around from prod to DR as well. Let's have a look at another important concept, which is shared VPC network. So when you use shared VPC, you designate a project as a host project. Let's name it test-env, and attach one or more service projects to it. So UAT-env and performance test-env, these two are our service projects. A shared VPC admin for the organization has created a host project and attached to service project to it. There is a shared VPC connectivity between these projects. Eligible resources from service project can use subnet in shared VPC network. Service project UAT-env can be configured to access all or some of the subnets in the shared VPC. And admin has created an instance in UAT1 in the zone US West 1 region. And this instance receives its internal IP address 10.0.1.5 from the subnet 10.0.1.0, subnet A. The same way, admin has created another instance BT1 in US East 1 region, and the instance receives its internal IP 10.0.4.8 from the CIDR 10.0.4.0/24. Shared VPCs allows an organization to connect resources from multiple projects to a common VPC network so that they can communicate each other securely and efficiently using the internal IP of that network. However, shared VPC only works for same organization. It won't allow you to connect the project from multiple organization that was there in VPC peering. So these two instances can now talk to each other via their private IPs, because those two private IPs have been created in the shared VPC network and there is already a connectivity between those. So this is how shared VPC network works. And you could have multiple host projects in an organization. So this is our test network, like what we have seen so far. You could have another network, which is prod network, and you could share it with your other service projects. However, each service project can only be attached to a single host network. So this DR-env is attached to this host project over here. So this cannot be attached to the test network. This is the limitation. Now let's do some quick knowledge check about what we have learned so far. Let's say if a VPC A is paired with VPC B and VPC B is paired with VPC C, does that mean VPC B and C are also paired automatically? Which IAM role is required to delete or create VPC connections? Shared VPC can be created between different organizations. Is that statement true or false? VPC peering can be created between different organizations. Is that statement true or false? And what are the most important steps that you have to take to create the VPC connection between VPC A and VPC B? So list down those two important steps. And if you know the answer of these questions, let me know in the comment section below. If you have trouble understanding any of these concepts that we have discussed so far, then also feel free to reach out to me and I will be more than happy to help you out. That's it for this video, guys. I will see you soon in the next video. I hope this was somewhat beneficial to you and you would have learned something out of it. If you did, please give it a thumbs up, share it with your friends, family, colleagues, and keep learning. Thank you very much for watching. Have a good day.